Hello everyone, so today we are going to do Leetcode daily challenge populating next right pointers in each node. So here we are given with a tree and we are required to do something like this. Means if we get to our first level node, means a node which is at the first level, then we are simply we need to do is we need to insert a null and simply point that particular node towards null because we are populating the right pointer of each level of our tree. So in that sense, we are doing like this. So then when we reach at next level, then 2 and 3 are there at the level. So we need to think that first node which is there, then we need to populate this first node of second level and its right pointer we are required to populate. So when right pointer is there for this particular, so we'll simply populate it with the 3, means our right pointer will be pointing towards this, and then our 3's right pointer will be simply pointing towards null. Basically not the right pointer as the question is mentioning, it's simply required to populate the next pointer. This is the one which is in the structure of the tree, because the right pointer of root would be 3 and the right pointer of 2 would be 5, right pointer of 3 would be 7, right? But we are required to populate the next pointer. So 1 to null, this is the next pointer which is being populated. Then 2 to 3, this is the next pointer which is being populated with 3, and 3's next pointer is being populated with null. Then we are given with 4, then 4's next would be 5 and 5 next would be 7 and 7's next would be null. So like this, we are required to simply populate the next pointer of each node towards the right. But the thing is that how we are required to do all these things. In from the question, we can see that it's all about doing level by level, right? So from this, like even if I say you that we can go towards the depth and do these things, then it would be much costly for us to do. So it's better to do it level by level only. Means when we are having okay, before that let me go through the constraints. So constraints are simply that number of nodes would be still 6,000, right? But as it is a binary tree, so these 6,000 would be divided also. Even if it is a skew tree, then also at max 6,000 and null towards each next pointer. That also works fine even if we do in nice manner. And then the values of the nodes, here the values of nodes are like not much taken into consideration, means not much valuable for the question. So now comes the part that how we are required to do this question. So for doing this question, the thing is that we are simply required to populate the next pointer with null or the next node which we are having, right? So for doing that thing, what we would be doing, we'll do a level or traversal and push each level nodes which are being there into the queue. Means level 1, then level 2, then level 3. So all the nodes which are being there at each level, we would be pushing all those nodes into the queue, right? First thing we are required to do this. Now this level's nodes are being pushed, then we will simply push null to it, because at the end we are required to populate it with null also, right? So whenever all the nodes of this particular level are being pushed into the queue, then we are also required to push null into this particular queue. And also one thing is there that we are also required to simply connect all these, right? So connecting all these means while we would be pushing all these into the queue, in meantime only when we are having that current node with us, what we'll do current next equals to whatsoever we are having in the front. Means if our current node is 2, then we'll simply connect this 2 with 3. This we are required to do. And then we'll at the end, when we see that now we don't have anything into the queue, or if we are having but our last node has been pushed into the queue, then we will simply push null to that, and then we'll again do this particular, right? So we would be doing this question like this. So yeah, somehow I have already to the intuition that how I would be required to do this question. Now comes the next part about time complexity and space complexity. So time complexity would be in our order of height only, where height could be from log n. When it is a densely populated, then it would be log n, and if it is a skew tree, then it would be n. So we could say that time complexity would be simply order of n, and the space complexity, because we are using queue, and at max, if it is a skew tree, right? If a tree is something like this, so all of them would be required to be pushed into the queue, right? So that's why space complexity will be order of n again. So like this, we are required to do this question. Now let me walk you through the code of this question. For the coding part, so here is the way I was explaining. Let me split this particular code into parts and explain you. Now comes the part doing BFS, right? So for BFS, we are required with this queue that I'm having now. Now, first thing which we are required to check is that is our tree empty or it is there. So this is the basic. If root is not present, that is, if root equals to null, then we are required to return null at that point only. Else, we will simply push that root in the queue and also push the null. Because this particular first node, it won't be having any other node with it, right? So with that only, we'll simply push the null also right away only. So now comes the part of doing BFS here. So how we are doing BFS here is that will check that if this is a standard BFS only, that if our queue is not empty, then we are processing the node. So we'll first take the first node from the queue, pop it from the queue, and now we'll start processing this node. Now we'll check that if it is not null, that is it is our root node itself or it is a null node which we have pushed, whichever node it is there, we'll check that if it is not null. So yeah, our root node is there, which is not null. So this thing we are required to do. The thing which I was saying, that while processing that node, we will simply connect the next pointer of that current node with the one which is there at the front of our queue. So this is what we would be doing. And then if our current node do have a left node and also do have a right node, means if it is having a left node, then we'll simply push our current node's left into the queue. If it is having a right node, then we'll simply push our current nodes right into the queue. So like this, at this point, one was simply popped out from the queue, and now our queue would be having null with it, right? And also, as it was having null, so it is now being connected because of this particular line. This particular line, it has been connected, and also as our current node was being processed, so now our queue would be having null. It would be having null, and then it would be having 2 and 3 because these are the left and right nodes of R1. So this is how our second level would be being pushed to the queue. Now comes the part, means after this particular position, it will means this point has been done, right? Now it will check. So now while loop would be there and it will check that is my queue empty or not. So yeah, it is not empty. So it will check for the current node. Now the current node would be simply equals to null because one was popped from the queue and now null is there. So now null would be there, null would be popped. Now it will check that if my current node is null or not. So yeah, it is null. So yes, it is null. And when our current node is being null, then at that point, one thing is there. Means while doing this question, I just noticed that because of this thing only, we are able to push the null into it. So when our current node is null, right? Till that point, all the nodes which were being there in that level, means the next level, would have been pushed there. So because of that thing only, we are able to check that if our current node is null, right? And also our queue is not empty, because when null is reached for current element, then at that moment current left and right would have been already pushed. That is the thing which I was saying. Thus we are required to push null for those also, because that level is filled. So we are required to now push null for this 2 and 3. So at this particular point, our queue would be having 2, 3 and null. So this would be the thing. Now our one level has been completed. So again this while loop will go ahead, and now our current node won't be null because now our current node would be having 2 as its value. So now other two children would be pushed into it, right? And then 2 is being popped, then 3 would be our current node, right? So 3 children would be pushed into this particular, and till then means when 2 would be done, 3 would be done, then this null would be again encountered. But when this null would be again encountered, till then the level third would be completely filled into a queue, and we could easily then push null to it. So this is how this question is eligible to pushing null at each level, because the BFS is being done in such a manner that whenever there is a node having some value other than null, then surely we are required to push all the children of that node. But if our present node is having null value, so till then our next level nodes have been completely filled at that moment, so we are required to push null for that particular level. So this is how this question is being done with populating our right side next pointer within null, and thus this is all about this question. If there's any doubt or anything, you could simply comment that down, and this was all for it. So yeah, thank you.